In this video, I'm going to be going through the 6.1 to 6.2 quiz review. Number 1 says, in a lab, 370 cells are present at the beginning of an experiment. During the first 9 hours, the number of cells increased by 10% each hour. Write an exponential model giving the number of cells present t hours after starting the experiment. Estimate the time when the number of cells is 600. So for this one, I'm using the formula y equals a times 1 plus r to the t. I can tell this because I'm not compounding, so I don't need to divide my r by anything. And I know it's plus because it says it's increasing. So it's going to be y equals, my a is 370. Then my rate is going to be 10 divided by 100, so 0.10 as a decimal. 1 plus 0.10 raised to the t power. Then it wants me to estimate the time when the number of cells is 600. What I want to do is I'm going to graph that first equation, and then I'm also going to graph, so I'm going to write down what I'm doing. When I graph the first equation, I'm going to switch that t into an x so the calculator will graph it. And then I want to see where these two graphs are crossing. So 370 times 1 plus 0.10 to the x, and then 600. I know my graph needs to go up to 600 to cover that y, so I'm going to go to window, and I want my, window, and I want to go down to my y max. I need this to be at least 600, so I'm just going to do 610, and then I'm going to go, graph it. So I want to see where these two are crossing, the red and the blue line. I'm going to go, second trace. I want where they're crossing, so that's going to be choice 5, intersect. I press enter for my blue line, enter for my red line, enter to guess again, and it gives me 5.07. This one wanted me to round, it doesn't say. It's nearest year, so it's going to be 5 years. The next one wants me to rewrite the function in the form y equals a times 1 plus r to the t, or y equals a times 1 minus r to the t, then state the growth or decay rate. So the first thing I'm going to do is I want to rewrite this so that the exponent with the number, so the 6 is going to go to my base, and then the variable part of the exponent stays on the outside. So if I do this on my calculator, I want to do 0.5 to the 1/6 power, which I'm going to do it out to 4 decimal places. So a times 0.8909 to the t power. It wants me to write it in the form 1 plus or minus r, so I need to subtract from 1 to get my difference. 1 minus 0.8909, oops, I missed my decimal. So it gets me 0.1091. This is smaller than 1, so it should be subtraction. So a times 1 minus 0.1091 to the t power. Growth or decay rate is the percent. Make sure you pay attention to this on the quiz. So I want to turn this decimal into a percent by multiplying by 100. That's going to be 10.91%. Pay attention to the rounding on the test. I think it might be tenths place, but it could be hundredths. So just pay attention to what the test tells you, or the quiz. Same thing on the next one. I'm going to do e to the 0.03. So what I typed in the calculator was just this part, the e to the point. Oh dang it, I typed that in wrong. This is what it should be. So 3499. So then it wants the rate change. So I'm going to do 1.3499 minus 1 gets me 0.3499 times by 100 to turn it back into a percent. It's going to give me 34.99%. Oh, the percent sign is already there. Okay, number 3 says the population of rabbits quadruples every 4 years. This means 4. So I want to have a base of 4. Another word might be triples. That would be a base of 3. So it wants me to find the yearly growth factor. So what I could do is I could write this out. I have y equals a times 4 to the t over 8. Because it happens every 8 years, I want to divide my exponent by 8. So just like before, I can rearrange this. So it's 4 to the 1/8 power to the t. I'm going to type that in to my calculator. This wants my growth factor. This is decimal with the 1 added or subtracted. So the 1.1892. What percent is the population change every year? So this is where I want to subtract from 1. So it gets me 0.1892 times by 100 to turn into a percent is 18.92%. Number 4 says my friend deposits $9,500 into an investment account that earns, so this is my A, 2.1% annual interest, so that is 0.021 as a decimal. Find the balance after 11 years when the interest is compounded quarterly, 4 quarters in a year. So for this one, I want to use the formula A equals P times 1 plus R over N to the NT power. So plugging in, I have 9,500 times 1 plus 0.021 divided by 4, so the 4 times 11. Then I just want to type that into my calculator. This is money, so I want to go to 2 decimal places. This is 11,961.43. Number 5 says I invest $1,700 in an account earning 8%. So my rate is 0.08 if I divide that by 100. Compounded continuously, this means I want to use my E function. So this one is going to be A equals P times E to the RT. So it wants me to write my function. A equals 1,700 times E to the 0.08 times T. I need my investment to double in 5 years. Will I reach my goal? If not, how much more time is needed? So just like earlier, I want to graph these two functions. I want to graph y equals 1,700 e to the 0.08x. So the calculator will graph it. And then doubling my investment is going to be 3,400. Because I just want to take the 1,700 and double that. So then I want to go ahead and graph this. So I have 1,700 e to the 0.08 x, and then I want 3,400. Oh, I forgot to change my window. I'm going to do 3,500. Okay, so I want to see when these two cross. That gives me 8.66. So it will not in 5 years. You need 3.5 more years. On the back, it wants me to match the situation with the exponential model, and then it gives me 10 different models. So, number 6 says the population of Mexico City, Mexico, in thousands after T years, when its current population is 8,851,000 with a 2.5% growth. So, I'm looking for something that has a 0.025% growth, and it says it's in thousands, so I want to take this number and divide by 1,000. That is going to be 8,851. So, I'm just going to go ahead and write this out. It's going to be y equals 8,851 times 1 plus 0.025 to the t. There's no compounding, so I shouldn't be dividing by anything. So adding that together should get me 1.025. That is C. The next one says the value of the boat T years after it was purchased for $8,851. When it decreases in value, that means to subtract, by 11.7%. So turning that into a decimal is 0.117. This is going to be y equals 8,851. 1 minus 0.117 to the t. I just want to do that math on the inside. I can't as easily tell that one. So it's 0.883 to the t. So that is choice B. Number 8 says the number of amoeba present T days after starting an experiment with 34 amoeba. That doubles every 6 days. So the way I write this is going to be y equals 34 times 2 to the t divided by 6. Oops, so that should be 1/6 power. Which gets me 34 times 1.122 to the t. That is A. Okay. Then the next one says the amount of time in grams the radioactive isotope manganese 52 remaining after T days, when my initial amount is 34 and halves every 6 days. So that means my base is going to be 1/2, and then my exponent is still T to the, or up to T over 6. So this one I want to do 1/2 to the 1/6 power. This one gets me 0.891 to the t, so that's H. My next one says the amount in dollars T years that pays 6.8 annual interest when the initial principal is 8,851 and it's compounded monthly. So I set this one up like normal. I have y equals the 8,851 times 1 plus 0.068 divided by 12 to the 12 times t. So I want to first start off by simplifying my inside. So 1 plus 0.068 divided by 12. And then I want to raise it to the 12th power. Oops. Because I would want to get rid of the number in the exponent. Go to oops. So this gets me 1.070 to the t, which is choice F. Number 11 says the value of a home in dollars can be approximated by this model, where t is the number of years since 2010. Decide if it's growth or decay. This number inside the parentheses is more than 1, so it's exponential growth. Identify the annual percent increase or decrease in the value of the home. So I'm going to do 1.09 minus 1, which gives me 0.09 times by 100 to turn it into a percent is 9% increase. And then estimate what year the value will be 839,000. So that's, again, I want to graph this. This is in thousands, so I want to take this number and divide by 1,000. So y equals 839. And then y equals 251 times 1.09 to the t power. So 839 and then 251 times 1.09 to the x. Oops. X if I'm graphing on the calculator. I'm going to change my window. We'll go up to 850. So, they don't cross on my screen, so I'm going to zoom out. And then I need to press enter, but first I want to arrow this cursor closer to where I want it to be. So over here on this right side. Now I can see them crossing, so I go second trace, then choice 5, enter on my first line, enter on my second, enter a third time, and this one says 14.0. So that's not my answer because it's years since 2010. I want to do 2010 plus 14, which gets me 2024. Number 12 says the table shows the value in thousands of the average salary of an NBA player X years after 1990. Write and use an exponential model to find the year when the average NBA player salary will be more than $4 million. So I want to create this into an equation. So I'm going to go to Stat, Edit. If my lists have numbers, I'm going to press Clear and then arrow down at the top of them. Then I want to enter my data in. And I go back home, and then I press Stat, Calc. I want an exponential regression, so that's choice 0, my bad. And I go all the way down to Calculate, I press Enter. So this is going to give me the equation. I plug in for A and B, so that's 12.5 times 2 to the x exponent. And then I want to see when this is going to be more than 4 million. This is in thousands, so I'm going to write out 4 million in numbers, and then divide by 1,000. So this is going to give me 4,000. I want to graph these two and see when they cross. My window, I want to make my Ymax go up to, let's do 4,100. Then second trace, 5 for intersect, enter for my first line, enter for my second, enter to guess. This one is 8.3. So that is 1990 plus 8, 1998.